Do you fancy having a go with a ZX81? Let me show you how to build one from scratch. Hi and welcome to Bytes and Bits. The Sinclair ZX81 will always hold a special place in my heart. It was in May 1982 that I had finally saved up 50% of the cost price of £70, and my dad had said that he would match me pound for my birthday. So I was finally able to buy a postal order down at the post office for one of these, and then send off for one of these amazing machines. When it duly arrived then, a few weeks later, my path into electronics and computers was firmly fixed. So fast forward to today, and I began to think that it would be great to have a play around with one of these machines. Not just on an emulator, but with actually a real ZX81 to get the full experience of using the machine as it was intended. Now fortunately, reality did hit, and I decided that although it would be a great project to set up a ZX81 system, for me, it would be something that I would only be using occasionally for a bit of fun. So the emulation route seemed the best way to go, which would let me avoid then having to sort of take care of all the old electronics, interface somehow with the UHF TV output from the ZX Spectrum, and so on. Now, if you've been following my channel, you'll already have seen my project to turn a real ZX Spectrum into a USB keyboard so that I could then use that with ZX Spectrum emulators. So I thought, why not do the same for a ZX81? So looking around on eBay for a case and keyboard didn't really turn up much for under £50, and even those did look a bit worse for wear, so I'd end up having to replace the keyboard memory and touch up the case and so on. But what if I could actually make my own case? I just then need to add the keyboard, the Arduino circuit, and I'd have the project working for around about £20. So my trusty Wanhao i3 duplicator had just enough room on its printer bed to cope with printing a case, and there was a great looking two-part model available on Thingiverse, so I was ready to go. So in this video, I'll show you all the steps to getting to my finished, built from scratch, sort of ZX81. So as I mentioned just now, the project relies on the skills of a talented 3D modeler who goes by the handle Sagittario. Now if you pop over to your Thingiverse account, you'll find the ZX81 case project ready for download. Now the base of the case is fairly straightforward to print, and you can see here me laying it out in my Cura slicer. But when it comes to the top, well, that actually comes in two flavours. Now, because the top half of the ZX81 case is quite awkwardly shaped, printing that flat requires the top surface to be supported from underneath. Now, that is a lot of support material, which will imply then a lot of cleaning up once you've printed it. So the actual designer has actually made a vertical print model that actually doesn't require any support material at all. So initially then I thought I would give this one a go. So for this print I used a wide brim to give me some good bed adhesion, and also then to try and give it a more stable base to limit the wobble as the print got taller and taller. So off it went, and the print went pretty well. So as you can see from here, the overall result was pretty good, but I did find that the flat surfaces weren't very flat, especially the area where the keyboard would sit, and I felt this just wasn't going to give a good reliable bed for the already dodgy membrane keyboard. Plus, I'd printed the top in my standard PLA filament, which gave it this very shiny sheen, and I didn't really like that on this project. So armed with a matte black filament and the flat printing model, I reprinted the top case, and this is what came out. Now unfortunately I totally forgot to film this before I built up the project, so please take my word for it that the keyboard bed came out much better with that support material on a flat surface, and the keyboard feels really nice and secure now that it's in place. So overall, the print quality is okay. I haven't felt the need to sand and polish this, as I'm sure that newer 3D printers will give a much better finish. Again, this is my 10-15-year-old printer. But anyway, so this is going to be my finished case, and as you can see here, my finished actual project. So with a suitable case, the only other main ZX81 part is the actual keyboard. So this is a membrane style design, which is basically a number of sheets of thin plastic sandwiched together with a printed circuit. And the circuit tracks are held slightly apart, so that when you press a key area, you actually bend the tracks until they touch, giving a button press. Now this was a great cost-saving exercise back in the day, but as for the feel of the keys,
Jesus, it's like trying to read Braille through a pair of gardening gloves.
So to source a keyboard, I didn't want to buy a second-hand one. After 40 years, I didn't feel that was going to be a good option. Now luckily there is a great supplier of brand new, re-engineered Sinclair parts called ZX Renew. Now I'd used them for my ZX Spectrum when I needed a new membrane, and they actually supply brand new ZX81 keyboards for only £13 plus postage. Now if you are based outside the UK, I do think that they ship internationally, so you should still be able to get hold of one. So now on to the Arduino part of the project. Now as I mentioned, this is going to be a rework of the ZX Spectrum circuit, which I used in this video here. So the circuit and code was designed to interface with pretty much any keyboard matrix, so we just need to work out the connections and mapping, and it should all fall into place. So first off, we need to work out the circuit used for the matrix. So looking online, you can find a number of ZX81 circuit diagrams, but they don't tend to show the pins on the membrane ribbon cables. So let's try to work out these with our multimeter. So from the diagrams, we know that the 8-way ribbon cable runs the rows and the 5-way the columns. Now to be honest, this is exactly the same as the ZX Spectrum with its 40 key layout, so the chances are that we're actually looking at the same circuit. So the matrix works by crossing rows and columns, with the key switches forming connections between a single row and a single column. So we know that row 1 on our keyboard should be the numbers 1 to 5. So what we'll do is we'll start off by connecting to the leftmost connector on each of the ribbon cables and seeing if that gives us row 1. So I'm just connecting things up here with my crocodile clips and just seeing if I can get a good connection on that, what I hope is row 1 pin. And if we now go and press those keys, just get a good connection here. Oh, I'll just hold this in place actually. Okay, so we've got that connecting now. Let's just try. So number 1, that's not the one. We go across. So there we have our number 5 key then is, so on our 8-way ribbon cable, that's obviously row 1 is the leftmost cable. So if I then try on what would be pin number 2, that was hopefully row 2, that should either be the 5 keys to the right of the 1, 2, 3, 4, 5, or the ones below it, the Q, W, E, R, T. And we are getting, and there we have a connection on the T. So we've obviously now got row 2, and if we go then across to row 3, this should now be the ones at the top there, and hopefully then, if we do that, we should get that going there. So, and there we have it on the, that was on the 6 key, wasn't it? Okay, so we're starting to get a feel for how this matrix is wired up then. And what we can do now is we can sort of go through and then tally up between the row numbers and the column numbers. So I'm obviously connected to column number 5 at the moment as I go through all these different rows. So let me go through that process and map out our keyboard matrix. And again, that should then match up with the circuit diagram that we found a little bit earlier on. So I've summarized all the keys then in this little spreadsheet here. And again, you can see that we've got all of our keys then laid out in our 8x5 matrix. So this is basically the same as the ZX Spectrum with just a couple of rows swapped around. So for the ribbon cables looking in this direction, I'm making the row and column numbers as shown in this diagram. So row 1 and column 1 are then side by side in the middle of this sort of layout. Now that we know which connection is which, we can complete our circuit diagram, which is basically identical to the one from our ZX Spectrum project. Note that we do need these small signal diodes on each row line to block feedback from one row to another. And again, all of the theory of how that circuit works then is covered in that ZX Spectrum USB keyboard video. So all that's left now is to build up the circuit. So I'm going to be using some double-sided matrix board here so that I can mount some components on both sides of the board. The actual holes in this one are through-hole plated so I can get good connections between both layers. Now, I did find that if I put the Arduino on top of the board, because I'm using some little stick-on standoffs to mount the circuit board in the case, the Arduino doesn't fit into the edge connector slot at the back of the ZX81. So if I mount it underneath, it just fits perfectly, and that then lets me then mount some more components on top of the board as well. So the ribbon cable connectors, of course, they're going to need to go on top of the circuit board so that the ribbon cables can plug into those. And then I'm going to be using some wire wrapping wire to simply wire it all together. And that then gives me a finished circuit board that looks like this. So all I need to do here is I need to fit on some of these little standoffs. And then just mount that into the case. So again, I'm just making sure that I line up my ribbon cables with the position of the circuit board, so that I'm not so that they'll just simply sort of bend over on themselves without having to sort of go left to right, which could then put kinks into the actual connectors. And once that's all in place, then I just need to then put the ribbon cables into those connectors and close up the case. And that then gives us our finished ZX81. So the Arduino code for this project then is going to be a rewrite of our ZX Spectrum USB keyboard. So I did a project a while ago where we turned a ZX Spectrum case into a USB keyboard, and that then allowed us to use that as an emulator keyboard. So this obviously is going to be very, very similar, but there's a couple of changes I had to make to that to cope with some peculiarities of the emulator I'm using here. So I'm using the 81 emulator in this project, and I'll come to those in a second. But basically this is the same as our ZX Spectrum USB keyboard. So it's based around this Arduino Pro Micro, which is a really good little microprocessor or microcontroller board for USB projects. It has built-in USB support, which means then, of course, that we can use the Arduino libraries and the Arduino keyboard library, which basically does everything for you. We just call a couple of methods on that, and we can then develop our own keyboard using this Arduino Pro Micro. So I did do a complete explanation of the code in the ZX Spectrum version of this project, and again, that's the one that's shown on screen at the moment, and I will put a link to that in the description. So if you want the full details of how it all works, then do please look through that. What I'm going to do in this version, I'm just going to go through the changes really that I've made to it. So if we come down here, the basic setup then is exactly the same as in the Spectrum one. I'm actually using exactly the same pins for the row and column drivers. And again, you can see we're just defining those there, putting them into arrays. The change here I've made, on the ZX Spectrum version, I added an extra push button outside of the keyboard, just so we can get some extra control. But I'm actually going to use one of the keys on the keyboard here. So we're going to use the new line button. And all I'm doing here is just telling us where in the matrix that exists. So we then have a key map, and this describes all of the keys and their various positions on our matrix. And you can see here it's just a two-dimensional array with our rows and our columns, and then each of the individual keys. So what we're doing here is we're defining which key on our normal PC keyboard we want to mimic when you press that particular key on the ZX Spectrum, ZX81 keyboard. And you can see that relates then into that matrix that I showed you with all of the key positions. Again, a couple of these are the predefined constants. So that's how we tell it that we want a shift key there or return key. And that's sort of just filling that out. This ZX81 emulator that I'm using, the 81 emulator, it did have a little peculiar thing with the full stop key or the period key. On a PC keyboard, when you press full stop, and if you then do shift full stop, you get the greater than sign. On the ZX81, shifted full stop is the comma, which of course is a separate key on a PC keyboard. So the 81 emulator uses the PC key definitions for that. When you do shift full stop, it does not do the ZX81 comma, it does the greater than sign. So I needed to create a way in which if we do have the shift key pressed when we press one of the keys on the ZX81 keyboard, that we have a method of allowing that to then send a different key press rather than the shifted version of its normal key. And that's what all this is doing here. So I've created a second map, which is a map of the shifted keys and what they represent. This /0, that's a null character. So basically, if I put a null character in there, that means that this particular key in the matrix does not have an alternate shifted version. So mostly they will all just give shifted versions of, so the A key will give a shifted A because it's got a null value in its shifted map. But of course down here we have the matching array position for our full stop key. And again, when we do a shifted full stop, that is actually going to send across a comma. And that will then mean that the 81 emulator will work correctly for us. So to get that to work then inside our keyboard key, so I actually defined two classes. Keyboard key class is able to do all the coding required to run a single keyboard key and does all the debouncing and so on. And you can see here that we're now giving it two key codes. So it has two possible keys that it can press. And down here a bit, when it comes to actually press the key, you can see here it's checking the state of the shift key. So if we have, if the key isn't shifted or if there's no alternate function, then we just do the normal key code going across. So that will then appear as just the normal key code, of course, with the shift key pressed down. If, however, we do have an alternate shift key, then this is what we have, it takes place here. So we will actually release the shift key. So we don't want to send this across as a shifted alternate key. We want to send it as a normal version of the alternate key, if that makes sense. So in this situation here, we release the shift key, so the PC does not see it as the shift being held down, and we then send our comma for our full stop. So that will just send across a normal press of the comma key on our keyboard, and that will then be how it works out and gives us the correct keyboard press. So that's a bit of a change on here. And again, that then does allow us then, as we go forwards using this piece of software, if any other emulators have other versions of the keyboard that don't match up with the keyboard symbols, then we can allow for that and we can program that into the system quite easily. So after that then, it's pretty much as it was before. The only other difference is that when we come to handle the scanning of the matrix, so we have here a matrix driver class which handles the scanning of the matrix. All it's doing there is it's passing in a reference to the shift key handler, which of course is part of this key handlers matrix or array here. So that's sort of how all that works. The rest of it then is I think it's actually identical. Again, as I say, apart from this bit at the start here. So really what's happening on this bit, this idea of this, I called it reset button here. It's almost like a pause button. The keyboard library, when we start running the actual keyboard, it actually takes over the USB port. And if something goes wrong in your software, it can actually lock your Arduino out from communicating with the Arduino IDE. So if we get into the keyboards area and it crashes and locks us out, if we don't have some way of pausing at the start to get control of that USB port, you can actually lock yourself out of your Arduino. And there are ways around it, but you have to short pins and do various other things to get back in control of it. So what happens here is we have it waiting for us to press the new line button on our ZX81 keyboard until we take over the USB port. So if we do crash, we just reset the Arduino, it waits for us here, we've got access then to the IDE, and we can reprogram it without any of the sort of messing around with resetting it and so on. So after that then, it's exactly as it was before. So we're just running the keyboard matrix, scanning our keys, and then sending key presses out over our USB port. So that's our code. I say everything's ready now, so we should be able to just load that up into our Arduino and test out our keyboard. So that's our code uploaded. So it should now be sitting there waiting for us to press the new line button. So if I press that, we should get that message coming up. So there we have it, recognizing that that's been pressed. So let me bring across a little notepad window now, if I can find that. There we have. So I come in here, we should now have a working keyboard through our ZX81 keyboard. So if I do this, and there we have it all working, and we should have our new line function. Now obviously then we have our shift button here, so if I shift, that should give me the shifted G key, so I get my capital G. The actual red lettering on the keyboard itself, that will be handled by the emulator. So at the moment this is operating as just a standard keyboard. So of course the shift key is just shifting our actual key. So if I do a shift and 4, again we're getting our shifted symbol keys coming up there. So the actual system is now working. So let's install this into the ZX81 case and then boot up the emulator and see if we can get a proper ZX81 running under our emulator. So we've got our ZX81 keyboard all plugged in, and I've activated it with the new line button. So let's see if we can actually do some coding on this computer. So we've got the emulator running. So let's start with a little for next loop. So for A, so shift plus L gives us our equal sign, and then shift plus 4 gives us our to keyword. So let's do that. And there we can see we now have that line of code entered. So line 20. So let's play around with our print statement then. So shift plus P gives us our inverted commas. And then we can go into graphics mode. So shift plus 9 puts us into graphics mode. And then we can type in these various graphics characters. So let's do some of those checkerboard patterns. If I come out of graphics mode, and then our shift plus X gives us a semicolon, which lets us print things all in one line. So I'll print some stuff here. So let's do some more graphics characters. So graphics, let's do sort of some of those ones there. Okay, so out of graphics mode, and that's our print statement done. And then 30 is our next A. So you can see there, so using the emulator, we now have access to a proper ZX81 keyboard, and we can then access all of our keywords here, and our symbols, and our shifted functions. So this is now letting us use this as a ZX81. Again, remember, this is working as a standard PC keyboard, so that's what we're emulating with our Arduino, but obviously then running through the emulator, it's working as a ZX81. So if we run that program, we should find we now have got some our little ZX81 code up and running. So that's our emulator now all working and giving us our proper sort of ZX81 experience. So that then is my sort of replica ZX81. Again, it is a USB keyboard, but using that in these emulators then lets me get the full experience of using the proper keyboard and I'm really just reliving my youth in effect. One of the real things which I love doing is picking up some of the old magazines and working through those. And I did actually find the very first version of Sinclair User that I ever had, which was the July 82 version. And inside that, I do remember this particular program, which I've just retyped in again, this bug beta. That was one that I used to type in before I actually had saved up enough money to buy a cassette recorder to be able to save the program, to save me having to type it in every single time I wanted to play it. So having another go at that now was really good fun, typing it all in and having a play with that game. So do have a think if you want to put ones together. As you've seen, again, if you do have a 3D printer, which will save you a couple of £100 in buying one of those, you can print the case. Okay, my printer is an old one, so even that is able to make a reasonable job of printing that out. The keyboard itself, head over to zxrenew.co.uk and pick up one of those for about 13 quid. Put it all together, and as you can see, the Arduino Pro Micro is only a couple of pounds as well, and you will very quickly have yourself your own ZX81 to mess around with. So I hope you found this useful and interesting. If so, please do click that like button and subscribe to the channel for lots more coding, making, electronic projects, gaming and modding videos. I look forward to seeing you again very soon, and bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.